Hi, this is Jessica Dunn, and we are going to work through the Chapter 5 practice problems. The first question says that we have $100 to invest and we can earn 12% on our investment. How long does it take for your money to double? So to increase to $200. So that's part A. So let's go ahead and work through part A. Remember, we always like to put things on a timeline. So today we have $100 to invest. Now, if we're thinking about using our financial calculator, remember that cash outflows are negative signs and cash inflows are positive signs. So if we have $100 to invest, we're taking $100 out of our pocket, putting it into an account that we are not going to touch for some period of time. So that $100 would be a negative 100. It's a cash outflow. Now, at some point, our investment is going to be worth $200. And at that point, we would withdraw it, and that would be a cash inflow. So at some point, we don't know when, our investment would be worth $200. And our interest rate is 12%. We are not making any additional deposit, so there is no payment. We're only making that one $100 initial deposit and nothing additional to that. So our present value, the negative 100, our future value is 200, the payment is 0, and our discount rate is 12%. So if we put that into our financial calculator, you should get that N is equal to 6.12 years. And I know that it's years because our time frame here, we're looking at an annual interest rate. So I know that whatever I saw for N, that is a yearly period. So to get to that in your financial calculator, it is just that third row of keys. In your graphing calculator, remember it's Apps, Finance, TVM Solver. You would put in these as seen and put your cursor beside N and push alpha enter. I don't know what type of calculator you're using. This is applicable for the graphing calculator, and that would solve for N. For those of you with a financial calculator, you would put these in, and then you would push compute, and then the letter N. So let me show you that on the financial calculator. I would first clear my time value of money. To do that, I push the second clear TVM button, which is also the future value button, and that just sets everything in this row to 0. So I put a negative 100 in for present value. So I type in the 100 and the negative sign, and then I push PV. There's no need to push enter. It's already saved. You can see that it's saved because there's an equal sign there. I'm going to put in the future value of 200, so I type in the 200 and I push the FV button. It's already saved, no reason to push anything else. The payment is 0, so 0 and then the payment button. The discount rate is 12%, or the compounding rate here in this instance is 12%. Remember, your calculator understands that you're using interest rates, which are decimal points, with the financial input. So you put a whole number 12 in here and it will know that it's 12%. The same is true with your graphing calculator. Now I want to solve for N, which is time. So I'm going to compute N, and I got 6.12 years. Now if I wanted to see what I had put into any of these buttons, I could use the recall button. So if I push recall future value, it shows me what I put into that field. If I push recall IY, it tells me what I use as the compounding rate. So it's a nice little check that you can do. Okay. Part B says, what if the discount rate or the compounding rate were 6%? So we're going to leave everything alone. We're essentially using the exact same timetable. So our present value is still a negative 100, and our future value is still a positive 200. Our payment is 0. Our discount rate is 6%. And we can solve for N. And I got 11.89. And again, we know that's years because we used an annual rate here. But let me show you how to work that on your financial calculator. So as always, we need to clear our time value of money. So second, clear TVM. That just resets everything to 0. We have a negative 100. Type in the 100, then the negative sign, and press present value. The future value is 200. So 200, and then the future value button. We're depositing no additional money, so our payment is 0. Our compounding rate is now 6%. Again, we can use a whole number 6 because your calculator already understands that we're working in interest rates. Compute time, which is N, and that gets us 11.9 periods. Here we know that that's years because we used an annual interest rate in our compounding. So if we were rounding, I didn't actually round correctly, it would be 11.9 years. So let me change that real fast. 11.90 years. So it didn't take exactly twice as long. So it took us, if we were earning 12% on our investment, it took 6.12 years for our initial deposit to double. If we were earning 6% on our investment, then it takes 11.9 years for our investment to double. So even though the rate was half as much, it doesn't take exactly twice as long for our initial deposit to double. And that's because of compounding. So over longer periods of time, there are more compounding frequencies. That interest is being added to the principal more often because it's a longer stretch of time. And so it gives a little bit longer for those initial periods to grow. So that initial compounding period there where interest is added to the principal, those early principal payments or those early interest payments that are being added to the principal have a very long time to grow over a 12-year period. So it doesn't exactly take double the amount of time. And that's because of compounding. Okay, so question 2 says, if you invested $4,500 today at 8% interest, what would that investment be worth in 7 years? So, first step is a timeline. Today, we are investing $4,500. So we are taking $4,500 out of our pocket and putting it into an investment vehicle. So that is money that we won't have access to for 7 years. So draw our timeline here. In 7 years, what would that $4,500 be worth if we can earn 8%? So let's put this into our time value of money calculator. Our present value is a negative 4,500. We're wanting to solve for future value. Our payment is 0 because we have no recurring cash flows. We're making that initial $4,500 deposit and we're not adding to it throughout the period. Our discount rate is 8%. This is compounded annually, so our compounding frequency is 1. So that's just an 8%. Our N is 7, again, because we have annual compounding, so that's just 7 because our compounding frequency is 1. Remember, it's N times M. So if we put that into our calculator, we can solve this problem. So the first step here is to clear our time value of money. So second, clear TVM. Our present value is a negative 4,500 because we took money out of our pocket and committed it to an investment vehicle for 7 years. So that's our present value. Our payment is 0 because we're adding nothing to this initial deposit. Our interest rate is 8%, and we're leaving it alone for 7 years. So I'm going to compute the future value, and I get $7,712.21. That's our future value. So one question I often get from students is, how do I know what I'm solving for? And I think that the key to answering that is always in the timeline. If you can fill out a timeline confidently, then you should always be able to identify exactly where things go. And if you can figure out 4 of the components, it doesn't matter which 4, the 5th one you can always solve for. So as long as you can identify that, yes, we deposited $4,500 today and nothing else, that would be the $4,500 as the present value, and payment would be 0. We also know that it's a 7-year period at 8%. So the only thing left to solve for at that point would be future value. So even if you somehow couldn't figure out that, well, I don't know if it's asking for, payment or future value or whatever you're confused upon, once you identify these 4 components, the only remaining option is future value. So it helps to do the timeline. It helps immensely. Okay, so here's another example. You want to purchase a car in 5 years. That car will cost you $14,000 at year 5. How much would you have to save each month to pay cash for the car if the annual interest rate is 2%? So here, there are different things that we need to notice. First of all, how much are we saving each month? So this is compounded monthly. So we need to make some adjustments here to our inputs. But let's first draw a timeline. Okay, so we have 5 years to save. And within each of those 5-year periods, we have 12 months. So 12 months into each one of these periods. And we're going to make a deposit into an account earning 2% every single month. I didn't draw my lines very uniform. So there we go. We have 12-month periods into each one of these. What do we have in the account today? We have nothing. We haven't started saving yet. How much do we need to have? We need to have $14,000. And we have 5 years to save it. We earn 2% on our savings account. So let's put in what we know. We know that the present value is 0 because we have nothing in this savings account yet. We know that the future value is $14,000 because the car is going to cost $14,000. We know that we have 5 years to make these deposits, and we're going to make them monthly. So we have 5 years times 12 months. So that's 60 deposits that we will make. And we know that we can earn 2% on our savings account, but we need to divide that by 12 because we're looking at monthly compounding. And so what does that leave us left to solve for? That leaves us to solve for payment. We need to solve for payment here. And when you solve for payment, you're going to get a negative answer, which makes sense when you think back towards our rule. Cash outflows are negative numbers. Cash inflows are positive numbers. Every month, you are going to take money out of your pocket and put it into a savings account earning 2%. So that's a negative cash flow. It's money leaving your pocket. Now the question asks, how much would you save each month? The correct answer would not be a negative, because by saying how much would you save, that means that you're going to be taking money out of your pocket and setting it aside, right? That implies that. So we know that the answer is going to be positive, but the answer that we solve for in our calculator is negative, because there's no such thing as negative savings. You can't save a negative amount of money. You can only save a positive amount of money. So the word save there implies a negative sign. So the first step is to clear the time value of money. So second, clear TVM. We have nothing in our account today, but we want to have $14,000. That's our future value. Our N is 5 times 12. If you didn't want to do the calculation beforehand, you could just do 5 times 12 in your calculator, solve for 60, and then push N. Same is true for the interest rate. 2 divided by 12 equals 0.167, and then I push the IY button. And now I'm going to compute the payment. If I save $222.06 every month, I will have $14,000 in 5 years, earning 2% on my savings account. So you're going to negative 222.06. But if we were going to state the answer in words, I would say that I must save $222.06 monthly to have $14,000 in 5 years. So notice what I mean. The negative sign implies a cash outflow, but here the word save also implies a negative cash flow. So your answer would be, for multiple choice, it would be a positive $222.06. Okay, let's do the next one. How much would you have to invest today at 12% to have $6,000 in 6 years? So let's do a timeline. We want to know how much would you have to invest today? How much do you need to put into an account today? We're going to leave that alone for 6 years. So we have 6 years, and we want to have $6,000 at the end of that 6th year. So let's put in what we know. We know that we want to have $6,000. We also know that we are not going to deposit anything after our initial deposit. So we're going to deposit money today, but then nothing else over the next 6 years. We want to make one deposit. So that means our payment is 0. We also know that we have 6 years to make this happen, and there's nothing here to imply that it's anything but annual compounding. So our compounding frequency is just 1. And we can earn 12%. So looking at this, the only thing left to solve for is present value. And again, we're going to get a negative sign here because that implies that money has to leave our pocket and go into an investment account to have the $6,000. So let's put this into our calculators. Second, clear time value of money. Future value is $6,000. The payment is 0. We have 6 years and we are earning 12%. Let's compute the present value. So the answer, a negative $3,039.79. Oh. So in words, we would say, I must deposit $3,039.79 today to have $6,000 in 6 years. So see how the words change? So the answer would be $3,039.79. Okay, here's the next problem, number 5. Which of the following is worth the most today? So by this question, we know that we're wanting to find the present value of each of these scenarios. The interest rate is 11%, so the discount rate is 11%. Okay, so option A, if we were going to receive $28,500 at the end of 3 years, today, 1, 2, and 3, receive $28,500, and we want to know how much that would be worth today. So our N is equal to 3. Our discount rate is equal to 11. And these are all compounded annually because there's nothing here to tell you otherwise. Our future value is $28,500. And our payment is 0 because we're not receiving anything other than that $28,500. So we can solve for present value. So the first step is to clear our time value of money. Second, clear TVM. We have 3 years at 11%. We're receiving $28,500 and nothing else. So let's compute that present value. And I get $20,838.95. So present value, $20,838.95. That's how much it would cost today to purchase. Or another way to word that is, if I were to, if we're deciding which of these alternatives is the best. So which one is actually the most money? Because it's not just a straight comparison. You can't compare money received in 3 years to money received in 9 years. So we're trying to make it an apples to apples comparison. So we want to know which one's actually worth the most money. And to do that, we have to bring them all back to the same point in time. So today, that $28,500 is actually worth $20,838.95. So let's look at option B. $54,000 at the end of 9 years. $54,000. How much is that worth today? So bringing an apples to apples comparison. 9 years at 11%. The future value is $54,000 and the payment is 0. How much would that be worth today? And whenever I calculated it, I got $21,109.94. Let me show you exactly how I did that. I had 9 years, 11%, nothing else received, and $54,000 in the end of the 9th year. Compute present value, $21,109.94. Okay, so now let's look at scenario C. $160,000 at the end of 20 years. So I just shortened my timeline a little bit. $160,000 at the end of 20 years. What is that worth today? Discount rate stays the same at 11%. Our future value is $160,000. And our payment is 0. So the present value here equal to 20 years, 11%, nothing additional received, and $160,000 at the end of the 20th year. So compute present value, and I get $19,845.43. So which of these would you rather receive? Would you rather receive $20,000 today, $21,000 today, or $19,000 today? I'm picking option B because that's the most money today. So you see when you're comparing this, 28,500 at the end of 3 years, 54,000 at the end of 9 years, or 160,000 at the end of 20 years, which would you rather have? You have to put those in an apples to apples comparison at the same point in time. So we bring them all back to today's money, and we see that 54,000 at the end of 9 years has the greatest present value. So it's the most money received. Because if you were to deposit $54,000 the $54,000 for the remaining time up to 20 years, you would have more than $160,000. If you were to deposit $28,500 for the remaining 17 years, you would also have more than $160,000. So it's not possible to make a comparison unless they're at the same point in time. Now, another way to make that same comparison, we could have simply taken option A and option B and found the future value of them at year 20. So we would have fast forwarded this 28,500 by 17 years and this one by 11, and then we would have been able to compare them all at the 20-year mark. I would have gotten us the same result. We've gotten the same ranking. Which one's worth the most money? It's always going to be option B. Okay, number 6, Marion Kirk wants to select the better of two 10-year annuities. An annuity C is an ordinary annuity. Remember, that happens at the end of the period. It pays $2,500 a year for 10 years. Annuity D is an annuity due of $2,200 per year for 10 years. So you receive that at the beginning of the year rather than the end. So if we're assuming that the rates are 10%, let's find the future value and the present value of both of these annuities. So let's write down what we know is going to be true across all scenarios. And we know that for annuity D, the payment is $2,200 per year for 10 years. So she would be receiving $2,200, so that's a positive number, for 10 years at 10%. But it does have to be in begin mode because it's an annuity due. For option C, the payment would be $2,500, 10 years at 10%, but this is an end mode because it's an ordinary annuity. So we need to know the difference. So let's find the future value. Option A asks us to find the future value of both annuities. So the information I wrote up here will not change. The payment's always going to be the same, the number of periods is always the same, and the discount rate is the same. So for annuity D, if we're finding the future value, that means that the present value must be 0. So then our payment would be $2,200, 10 years at 10%, and we can calculate the future value. Now when I did this, I got the future value to be $38,568.57. Let me first show you how to get it into begin mode. So to put your calculator in begin mode, you push the second button, then the payment button. Notice that it has the BGN written in black letters above the key. So we push the payment button. Now our calculator tells us it's currently in end mode, but to change that, you need to use the set button. So to set, it's second and enter. Notice set is written above the enter button. Now it says calculator's in begin mode. If I clear out of this BGN stays in the upper right hand corner. as a constant reminder that, hey, you're in begin mode. If it's in end mode, this goes away. But this is just telling me that the calculator is in begin mode. So let's go ahead and work annuity D. $2,200 payment. Present value is 0. 10% for 10 years. Notice I didn't type the 10 twice because it was going to be the same. It takes whatever's on the screen. So if I push recall IY, it has a 10 in there. Push recall N, it also has a 10. So just checking. And I'm going to compute the future value, $38,568.57. Now I'm going to go ahead and do part B for annuity D, that annuity due, because I already have the information put into my calculator. So here all I'm doing to calculate the present value, I'm just going to put a 0 in for the future value and compute the present value. And I get $14,869.85. So let me write that down. So the future value is 0. And for the present value, I got $14,869.85. So now let's do this for C. For C, at part A, finding the future value, we set the present value equal to 0, and we solve for future value. I do need to first take my calculator out of begin mode. I know it's in begin mode because the BGN in the upper right hand corner. So second payment tells me it's in begin mode, but hey, if you want to change that, push the set button. So second set. I clear out of that menu, and there's no more BGN in the upper right hand corner. So I know that I'm in end mode. So for annuity C, the payment is $2,500 for 10 years at 10%. And the present value is 0 for question A. And I'm going to compute the future value. And I get $39,843.56. Now for part B, it asked me to find the present value, so I would just put a 0 in for future value and solve for present value. And I get $15,361.42. So $39,843.56. Solving for present value, I got $15,361.42. So this doesn't really ask like a specific question. This is just telling you to calculate the future value or present value. If I wanted to word this in a question, I could say, how much would you have to pay today to purchase an annuity that paid $2,500 per year for 10 years? Or how much would you have to pay today to purchase an annuity due that paid $2,200 for 10 years? In that instance, we would want to solve for present value because we're wanting to know how much would we have to pay today. Another question that I could have asked would have been, if I had put this money into a savings account for 10 years, one that paid as an ordinary annuity, if I immediately put that into a savings account, $2,500 for 10 years, or if I put annuity D, the annuity due, into an account and deposited $2,200 per year for 10 years, how much would I have at the end of that 10-year period? In that instance, you would have solved for future value. So notice there wasn't a question asked. It was just telling you to do both exercises. But they could easily be converted into actual questions. Okay, number 7. Hal Thomas is a 25-year-old and he wants to retire when he's 65. If he can deposit $2,000 a year into a tax-deferred IRA that earns 10%, how much will he have when he retires? So let's draw a timeline. Today, Hal has nothing in his account. There's $0. So our present value is 0. There's nothing in his account. Now he's going to start making deposits. Let me make that a little bit prettier. He's going to start making deposits, and he's going to make them for the next 40 years. So he can deposit $2,000 every single year. How much will he have at retirement? So we know that we're looking at an annuity here because the cash flows are equal, periodic, and finite. The 3 qualifications for using your payment button: equal, periodic, and finite. So the payment is $2,000. Now, if he's depositing that $2,000, I would put that in as a negative because he's not touching it. He's setting it up as something that he will leave alone until retirement. So he's putting that into his account. It's coming out of his pocket. So it's a negative $2,000. He's making annual contributions, not monthly. So we know that this is compounded annually. So it's 40 time periods. And his account earns 10% on average. So we need to solve for future value. Step 1 is to clear our time value of money. We have nothing saved today, but we're going to start making contributions of $2,000 per period for 40 years. And we expect to earn 10% on that investment. How much is it worth in 40 years? $885,185. Part B of this question asks us, what if he waits until he is 35 to start saving money? So instead of having 40 years of contributions, he only has 30 years. So essentially the only thing changing in this problem is our N is going to be 30 instead of 40. So he still has nothing in his account today. And he still plans on making $2,000 contributions every year, but he's just delaying it for 10 years. Oh, sorry, I need to change that to 30. We want to know how much will he have at the end of the 30th year. So present value is still 0. Our payment is still a negative $2,000. N has changed though. It's now 30 years. But we're still earning 10% on our investment. So when we solve for future value, I got $328,988. So I'm going to keep the same inputs. I'm just going to change into 30. I'm going to compute the future value. And we get $328,988.05. So by waiting 10 years, he has $560,000-ish less money. Even though a 10-year period is only $20,000 in contributions because he's making $2,000 each year times 10 years, so that's $20,000. He's only depositing $20,000 less, but he has $500 and roughly $60,000 less money because he's lost that compounding time. So time is very important, even more important than amount when looking at long-term goals. Okay, let's look at the next question, number 8, and the final question. An insurance agent is trying to sell you an immediate retirement annuity. For a single amount paid today, you will receive $12,000 at the end of each year for the next 25 years. You currently earn 9% on similar risk as assets. Ignoring taxes, what is the most you would pay for this annuity? Okay, so it's going to pay you $12,000 at the end of each year. So at the end of the year, that indicates that it's an ordinary annuity. So your calculator will be in end mode. It's for 25 years on 9%. How much would you pay for this annuity? So how much would you pay indicates present value. So it's wanting you to solve for present value. How much would you pay today for this annuity? So how much would you pay today to receive $12,000 every year for 25 years? So our N, 25 years. Our payment is $12,000 per year. Our future value is 0 because we're going to pay money today for this annuity that pays us $12,000 and it doesn't make any additional payments beyond that 25-year period. So our future value is 0. I know there's a cash flow listed here above that $12,000, but remember the annuity button assumes that there is a cash flow every single period, including that final period. N is 25 years, and we need to solve for present value. So first step is to clear our time value of money. We have 25 years. We earn, 9%. Forgot to write that down. I wrote N twice. I didn't write down IY. Our payment is $12,000. And our future value is 0. Let's compute present value. And I got $117,871. $117,870.96. That'll come up as a negative sign because that's how much you'd be willing to pay for this. Would you pay more? You would not, because if you paid more than this amount, that means you would be earning less than your required return because you must earn 9%. Would you pay less than $117,870.96? Absolutely. Because if you pay less than $117,870, then you're earning more than 9% on this investment. And 9% is the cutoff. So I hope that helps with your calculations.